Hello students. In this session we are going to discuss about basic concepts of DC circuits, which is the first unit of basic electrical engineering. So moving into the topic, here we need to know that every object in the nature is made up of small molecules. Okay, these molecules are again divided into center part called nucleus, and it is divided into protons, neutrons and electrons. So here in this picture you can see that the atom size is 10 power minus 8 centimeter, and the size of the nucleus is 10 power minus 12, and the size of the proton and neutron and electrons are approximately 10 power minus 13, right? So here you can see in this picture that the atom is surrounded with electrons on the outer part, and the center part of this atom is known as nucleus, right? So these electrons are having negative particles, and the nucleus contains two parts, one is proton and neutron. The neutron does not has any charge, whereas proton is positive charge particle. So in this subject, we are going to only concentrate about this outer particle known as electron. Okay, so why we are considering this electron? This electron is a particle depending on which we can divide the materials into semiconductors, insulators and conductors. Now what is conductor? Conductor is a element which allows the flow of current. Okay, which allows the flow of current. Whereas insulator is a material which opposes the flow of current, which opposes the flow of current. Whereas semiconductor is a material which can be used as an insulator or can be used as a conductor, depending upon the electrons present in the outermost orbit of the material. So here this valency band is important for this materials. That is, whenever you want a material to be a conductor, that means the valency band should be electrons filled of electrons, and the energy gap for this material should be very low. That means the valency band and the conduction band should have a very small gap. Whereas for insulator, this energy gap will be very high, that is approximately 5 electron volts. Whereas for semiconductor, it lies between 0.7 to 2 electron volts. And the materials for which these examples are, that is conductor, it is silver, copper, iron, lead. So these are the materials which are used as conductors. That means these are the materials which can be used for the flow of current. Whereas insulator, it is glass, quartz, porcelain, paper, etc. So these are the materials which does not allow the flow of current. Whereas coming to semiconductor, here there are mainly germanium and silicon, which are highly used material for semiconductor, or the materials which are used for production of electronic devices. So moving on further, first thing what we have to know is free electron. Now what is free electron? The electron which are present in the outermost orbit of an atom are known as free electron. So these free electrons are free to move from valency band to conduction band. So valency band to conduction band. So due to this movement of electrons from valency band to conduction band, there is a flow of current, or the current starts flowing from the supply to the load. Coming to the next one, that is charge. So what is charge? In practice, coulomb is used as the unit of charge. Now what is charge? This electron is having some amount of charge. Okay, so which is given as one electron is having a charge of 1.602 into 10 power minus 19 coulomb. That means to create 1 coulomb of charge, we require 625 into 10 power 16 electrons. 625 into 10 power 16 electrons will give you 1 coulomb of charge. So you just need to remember that charge is used for representing the electrons, that is these units are coulombs. Next, electric current. What is electric current? Electric current is nothing but the movement of electrons. The movement of electrons. So the flow of free electrons in a definite direction is called electric current and is measured in amperes. Or you can also define this electric current as the rate of flow of charge. Okay, so the rate of flow of charge means the time variation of charge is known as current. So here I am representing it as I. I is the representation of current, which is equal to rate of flow of charge. Or you can also write I is equals to dq by dt. Next, these units of this current are amperes, units of charge is coulomb, units of time is second. So, current is nothing but, that is ampere is nothing but coulombs per second. So, this type of questions can be asked in your objective or competitive exam, that what is the unit of coulombs per second, that is nothing but amperes. Next, moving on to electric potential or potential energy or electromotive force. Now, what is this? This is nothing but the energy required for the movement of electrons. So, as I was saying that electrons will be moving from valency band to conduction band. So, how they will be moving? So, to move or to do some work, we require some energy, right? We require some energy. That energy is nothing but known as electric potential or potential energy or electromotive force, that is the force required for the movement of electrons. The force required for the movement of electrons is known as electromotive force. So for example, you consider here this as an conductor. This as an conductor which are having electrons, which are having electrons in it. So to move this electron from one place to another, there should be some energy given to this electron. So that energy is nothing but your electromotive force or potential energy or electric potential, or it is also known as voltage, or it is also known as voltage. So the representation of voltage will be like this. One line will be bigger and the other line will be smaller, and V is the representation of voltage. So whenever this voltage is given, as this electron is negative charged particle, it try to attract to the positive plate of this voltage. It try to attract to the positive plate of this voltage. So the flow of current will take place when there is a movement of electrons from one place to another place. That means from this to this. But we will always take the direction of current as from positive plate to negative plate, from positive plate to negative plate. So this is nothing but your current. Okay. So what is the units of voltage? It is nothing but volts. Now what is the volt? It is a work done per moving a charge, right? Work done per moving a charge. So work is always measured in joules, and charge it is Q. So joules per coulombs, because the charge unit are nothing but coulombs. So joules per coulombs is known as volts. This you need to remember for your objective bits. Joules per coulombs is equals to volt, right? So in this figure, like if you observe this figure, you will see that there are two tanks A and B. There are two tanks A and B. So what is the difference between this first figure and second figure? If you observe here the level of water in tank A is equal to level of water in tank B. That means when there is a equal amount of pressure on both the tanks, then there won't be any flow of water from one tank to another tank. If we want to flow the water from one tank to another tank, what we have to, one, the level of water in one tank should be greater than the level of water in other tank, so that the pressure on the tank A makes the water to flow through tank B. Okay. Next, moving on, this is energy. Energy is represented as W. Energy is represented as W, and we know that energy is nothing but capacity to do work. Here, the units of energy are joules, and it also be defined with an equation W equal to P into T. Now, what is P? P is nothing but power. Power is the rate of energy. The rate of energy, and the units are watts. So, what is P is equals to rate? Rate means d by dt of W. Okay, d by dt of W. So here this can also can be splitted like this: dw by dq into dq by dt. Now we have already seen in a previous slide that dw by dq is nothing but v, and dq by dt is nothing but I. So the power is always represented with this equation P equal to VI, and the units are watts. Okay, so till now we have learnt about what is molecule, what is atom, what is proton, what is electron, what is neutron. Next, we have learnt about free electrons, charge, current, potential energy or voltage, and potential difference, and energy and power. Right. So here we have to remember about potential energy, that is voltage. Okay, what is the purpose of voltage? Voltage, it is the energy given for the flow of or movement of electrons. Right, the energy given for the movement of electrons. Now, what is current? When there is movement of electrons, then the current starts flowing. The definition of current is the rate of flow of electrons. Next, what is potential difference? When there is a potential difference between 2 points, that means the 2 points of the voltage source are having different values, then only there will be the movement of current or movement of electron. If the potential difference is zero, then there won't be any flow of current. Right. So moving on to the next topic, that is Ohm's law. This is the very important topic for electrical engineering students. Okay, because Ohms is a person, he is a scientist who has given the definition and relation between current and voltages. So depending on this law, we are going to do much more problems, and we are going to learn the circuit very carefully. Okay, so try to remember this statement, that is Ohm's law states that the current through the conductor be, the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. The current flowing through the conductor. So let me draw a conductor like this. Conductor is nothing but a material which allows the flow of current, right? This is the conductor. So the current flowing through a conductor between 2 points. So this is A and B, 2 points. Okay, a current is flowing, that is represented by I, is directly proportional to the voltage across the 2 points. Voltage across the 2 points. Or you can also state that at the constant temperature, the current flowing through the conductor is directly proportional to the voltage applied across these terminals. Here you need to add on keeping physical conditions constant. Physical conditions mean there won't be any change in temperature, there won't be any change in pressure and all those things. Okay, so you can also state like this, or you can also state that this. Ohm's law states that at constant temperature, the current flowing through the conductor is directly proportional to the voltage applied across its terminals. So these are the terminals A and B. We are applying a voltage V, and whenever we apply the voltage V, that is potential energy, then electron starts flowing or electron starts moving, thereby current starts flowing through the conductor. Okay, so I am representing like this. This is my output, right? Current is my output and voltage is my input, right? So to remove this proportionality, I am placing a proportionality constant which is known as R. Okay, now what is R? R is the resistance of the circuit. Resistance of the circuit. Now what is this resistance? Resistance is the opposition caused to the flow of current. Resistance is the opposition caused to the flow of current. Now why this opposition caused? We'll see. Okay, so this is a conductor. Here there are so many electrons with a definite direction. Okay, so when there is some energy given to one electron, let us take this is the electron which is given some energy. What this electron will do? It starts moving. So will it move in a linear direction? May not be. So it may take or go and collide with some other material, some other electron. Thereby it loses some energy. Again, this electron collides with another electron and this loses some energy. So due to the collision of electron inside the conductor, due to the collision of electron inside the conductor, okay, inside the conductor, there is some energy loss occurring in the conductor. There is some energy loss occurring in the conductor. So this energy loss is represented as resistance. Okay. So this is R. The symbolic representation of resistor is like this. That means the maximum and minimum point should be same. So this is R. Okay. So from this, whenever we are given in a numerical the value of voltage, the value of current, then you can find out the value of resistor. If we are given with value of current and resistor, we can find out the value of voltage. So this is the formula which is used to find out the parameters, which is used to find out the parameters, and this is obtained by knowing the statement of Ohm's law. Okay, so the resistance is the element, resistance or resistor is the element which opposes the flow of current, which opposes flow of current. Okay, why it is getting opposed? It is getting opposed because this electron is not moving linearly. It is colliding with the other electrons in the conductor. So there is some heat energy produced. So that is we are going to represent it as a resistor. Okay. So the units of resistor is ohms. Now what is the difference between resistor and resistance? Resistor is the element. Okay, resistance is the value of the element, is the value of the element. Okay, now we are going to see how to find out this resistance value. Okay, so before that I have placed a picture here where you can see that we are just recollecting or resembling the voltage, current and resistor with a tank of water. Okay, so in this tank, if you can see, in this tank, or like on the right side of the figure, if you observe, in this tank you can see that the water level of both the tanks are same. Water level of both the tanks are same, and pressure, that is air pressure in the tank, is also same. Air pressure in the tank is also same. Okay, so the difference between these two circuits is that due to the presence of this nozzle, there is no flow of current or no flow of water through this nozzle. Okay, whenever this nozzle is opened, then there is a flow of water. That means this nozzle is represented or related to resistance. Okay, this pressure is related to voltage, this water is representing a current. So when there is a high resistance, then there won't be any flow of current. When there is no or low resistance, then there will be a flow of current. Right? Then there will be a flow of current. That means as the resistance is more, then the current will be less. So here you can see as the nozzle is opened slowly, then there will be a path created for the flow of water. Similarly, as the resistance is low, then the flow of current will be there. So these two are inversely proportional. These two are inversely proportional. So R is inversely proportional to I, or I is inversely proportional to R. So whatever is high, then the counterpart will be low. So if resistance is high, current will be low. If resistance is low, current will be high. So a conductor is a material which has low resistance, so that thereby the current flowing through them is high. Whereas coming to insulator, insulator is a material which has high resistance, so there won't be any flow of current. Okay, so the difference between insulator and conductor, you can just remember it like this. So let us move on to find out the value of resistance. So this is a color band of resistor. Okay. So there will be actually either 5 or 6 color bands. We are only going with 4 color band. Okay. So the color is represented here. Okay, the color is represented here. The color which is black, it has the value of 0. With brown, it has the value of 1. Red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, and white 9. So here you can represent this as BB Roy of Great Britain had a very good wife. Okay, so BB Roy of Great Britain had a very good wife. That is, first B represents black, second B is for brown, red R, O orange, Y yellow, G green, P blue, V violet, G gray, and W is for white. Okay, so here you will be finding a resistor with this color bands. Okay, what these color bands represent? So the first color band it represents any of the value. Second color band is also representing any of the value. Third color band represents the multiplier of this value, and fourth will be tolerance. Fourth will be tolerance. So usually we will be having for tolerance either gold with a tolerance of plus or minus 5%, silver with a tolerance of plus or minus 10%, and no color with a tolerance of plus or minus 20%. So here you can see for the color band of green, blue, yellow, and gold, the value is 560. So let us see how it is 560. So what is the, here I'll write. So green, blue, yellow, and gold. Okay. So what is the value of green? Green, it is 5. Green, it is 5. Next, what is the value of blue? Blue, it is 6. Next, what is the value of white? That is 4. 4, here you are going to write it as 10 power 4. Next, what is the value of gold? It is nothing but 5%. Okay, it is nothing but 5%. So plus or minus 5%. Okay, now what is 5%? Here 560 into 10 power 3 plus or minus 5%. That means 5% of 560 into 10 power 3, if we add and subtract this number, you will be getting the maximum value and minimum value of resistor. Why we require this maximum and minimum value is that due to the aging, that is due to the composition of the material by which this resistor is made of, there will be some difference in resistance value depending on aging and temperature. So for that reason, we require to know what is the minimum and maximum value of this resistor, even though exact value of this resistor is 560 kilo ohms. 560 kilo ohms. Okay. So moving to next, this is another chart of resistor color codes. Okay, resistor color codes. Here also you can see what we have done. This is for first digit, that is yellow. So yellow is 4, violet is 7, and red is 2, that is 10 power 2. 10 power 2 is 100. Next G is gold, so it is plus or minus 5%. So it is 4700. It should be 4.7 kilo ohm. It is 4.7 kilo ohm plus or minus 5%. Okay, plus or minus 5% of 4.7. Difference between 4 to 5 kilo ohms. So let us. I want you people to solve or find the value of resistor using this color codes and let me know and let me solve for this. Okay, so for this resistor I'm going to solve. First is orange, white, orange, gold. So what is the value of orange? You can see that the value of orange is 3, right? So it is 3. What is the value of white? White, it is 9. Okay, so 3 9 into 10 power 3 plus or minus 5%. Okay, so 3 9 into 10 power 3 plus or minus 5% of 5 into 100, uh, 5 by 100 of 3 9 into 10 power. Okay,